Alright, this is a turbine I made using the Fisher and Paykel washing machine motor, and then I rewired it for a 6x2 configuration. So it's got 6 series of 2 coils broken up. So the voltage goes into the wire and dumps amperage in, and out comes less voltage and more amperage. Cool. That's that. And I wired 5 of these, all in different configurations. This is a delta. No, it's a star configuration. And 3-phase AC. This is the hub that goes on it. And so now getting it on the center thing, using the original shaft from the washing machine, which is a 25 millimeter width, this way, 25 millimeter, which the American standard axles, this, are 1 inch. So, but I'm utilizing the fact that this comes with a shaft with a threaded end and a splined end with a nut on it. And so, by a 100 millimeter tapered, a 25 millimeter tapered bearing, and this goes over the shaft and sets right on that ridge down there. That just happened to be on there from whatever distance they needed on the washing machine. Just miraculously happens to fit this. That goes on there. And then this hub, trailer hub, that is a 25 millimeter bearing setup, and it also is, the stud distance is 101 millimeter. So that's good, because when I make my wing assembly, I buy a 100 millimeter bolt pattern brake disc, and I'll show you that later. Anyway, so then this, with one modification that I have to do, because this stator needs to be perfectly centered. The distance between this and the magnets in here are like 20 thousandths of an inch, so this can't be off center or it's going to rub, and you're going to need to grind them down on it, and it's nothing but a pain in the, you know what. So, the best thing to do is have one of these rings. I didn't do this yet. Have one of these rings machined this thickness and tapped. Have the end of this turned down on a lathe and weld this on there. Because if it's perfectly level, this is perfectly level with what the top of the axle, this miraculously fits perfect. This is what you call a farmer weld, and I did that. And I did one of these thin things because I didn't have this at the time. And I didn't have access to a machine shop, so I ground this down rather than grinding the middle of this. I ground this down and fit it on there and welded it, and then welded bolts behind it. And then I made this plate, this attachment thing, which is, these are 4 inches on center, just so that they're like interchangeable with all my other ones. And I welded this 3-inch pipe or whatever it is on there. Had the holes so that 100 millimeters apart, 101 millimeter. That fits in like that. And then these get nutted on for these. So one of these. Lock up. Working in the man cave. Okay, that's on. Now the next thing that happens is this bearing needs to be greased up. So, because springtime's coming, this stuff right here, synthetic lubricating grease, is thinner in viscosity so that it, in the wintertime when it's absolutely freezing, I usually use, in the wintertime I'll use Marvel Mystery Oil for the bearings because it's not going like outrageously fast. There's not a whole lot of pressure on it, and it gets 20 below zero, so nothing freezes up. So now we're going to grease these bearings up. It's windy today. The other turbine's going like crazy out there. Look at it. Spinning like crazy. How many volts we getting? Let's see. 12 volts. Pretty good. Okay. Let's see. It's on the top over here. Toss that out. And get this bit. Oh yeah, baby. There's one. Get it right down there in them bearings. Spring's supposedly showing up pretty soon, so having grease in here shouldn't slow it down too much on low wind days. Good. Okay, now this goes like this.